Nomenclature of cyclic alkenes. When you have a double bond in a cyclic structure, then it is called a cyclic alkene. A simple example could be cyclohexene. So here in this case, you can see that there are totally 6 carbons, and therefore it is going to be cyclohexene because you have a double bond. And this double bond by default is going to occupy position 1, and therefore you don't have to put the 1 in the front of it. You just need to leave it as it is. So it is understood that the double bond is going to be at position 1 of the ring. Okay, now let's do some examples here. Our first example is a cyclopentene ring. Okay, and by default, this double bond is going to be at position 1. We can choose this one to be carbon number 1, or we can choose this one to be carbon number 1. But which one is the right numbering? In which direction are we going to go in? If we are going to choose this to be the carbon number 1, then we have to go all the way around the molecule to reach the substituent on the ring. But if you're going to choose this one to be our carbon number 1, then you can go in the clockwise direction to reach the substituent on the ring with the shortest distance. Right? So the numbering for this molecule is going to go in this direction. Okay, now what would be the name for this molecule? We can see that there is a cyclopentene ring, and on cyclopentene ring is present an ethyl group. Right? Cyclopentene, and you don't have to put the 1 for the double bond for the presence of the double bond. By default, it is understood that it is still at position 1. Now, where is the position of the ethyl group? It is at position 3. Therefore, this is going to be 3-ethyl cyclopentene. Let's go ahead and do the next problem. Okay, this is a cyclohexene ring structure. And we have to assign either this is carbon number 1 or this is carbon number 1. Okay, now which one are we going to assign? If we assign this to be carbon number 1, we cannot go in this direction, right? We have to pass through the double bond, reach the first substituent present on the ring, and then from there we have to go on to the second substituent. Let's see what would be the number that we'll be getting for the substituents here. So this is 2, 3, 4, 5. So you have 2 substituents, 2 methyl substituents, one at position 4 and the other one at position 5. You need to make sure that the double bond gets the position 1, right? So the name for this molecule is going to be 4,5 dimethyl cyclohexene. Now, can we choose this as carbon number 1? Let's see what's going to happen if we choose that to be carbon number 1. If we choose this to be carbon number 1, we cannot go in this direction because we need to pass through the double bond, get to the second substituent, and then to the third substituent. So we have to go in this direction. Okay, if we go in this direction, the name is going to be cyclohexene again. And where are the 2 substituents, 2 methyl substituents present? It is again present on position 4 and position 5. So it doesn't really matter whether you choose this one to be carbon 1 or this one to be carbon 1. But always make sure that once you choose the carbon, you need to make sure that you pass through the double bond, reach the second substituent and the third substituent, and so on. Let's go on to the next one. This is again another cyclohexene molecule. And we have to choose either one of these the carbons as carbon number 1. Which one are we going to choose? If we choose this to be carbon number 1, then we cannot go in this direction. We can only go in this direction. So if we go in this direction, let's see what's the numbering is like for the substituents. So that puts the ethyl substituent in 5th position and the methyl substituent in 6th position. But if we choose the other carbon, number 1, then we can go in this direction, reach the substituents with the lowest possible number. So this is going to be 2, 3, 4. So that way we'll have the ethyl group at position 4 and the methyl group at position 3. So which one is the smaller number? So obviously 4 and 3 are smaller numbers compared to 5 and 6. So we have to adopt this numbering. And therefore the name for this molecule is going to be 4-ethyl 3-methyl cyclohexene. Some more examples on cyclic alkenes. When you have a double bond and also a substituent present on a carbon, then you have to choose that to be carbon number 1. Okay, and then After you choose that to be carbon number 1, you have to pass through the double bond and then get to the substituents present on the ring, making sure that you cover the shortest distance. So for this molecule, this is going to be carbon number 1, and this is carbon 2, 4, 5, 6. So the name for this molecule is going to be, the parent name for this molecule is going to be cyclohexene. And by default, this double bond is going to be at position 1, so you don't have to be worried about putting the 1 in the front. You shouldn't put the number 1 in the front. Okay, and leaving that double bond, we have 2 chlorines, and these 2 chlorines are present, one at position 1 and the other one at position 6. And therefore, this is going to be 1,6 dichlorocyclohexane. That would be the name for this molecule. Let's go on to the next one. Now, you have a double bond and you also have a substituent on one of the carbons which has a double bond, right? So by default, you are going to choose this to be number 1, and you have to pass through the double bond to get to the substituents in the ring. So you have to by default go in this direction. So this is also going to be cyclohexene. And on the cyclohexene molecule is present an ethyl group and also a methyl group. The ethyl group is at position 5. And since E comes first in the alphabet, you have to put that in the front. So it's going to be 5-ethyl. And the methyl group is present at position 1. And it's going to be 1-methyl cyclohexene. So this would be the complete name for this molecule. What is the IUPAC name for this molecule? The longest carbon-carbon chain is here, which has got a total of 8 carbons. And therefore, this is going to be octene. Now, where is the position of the double bond? What is the position of the double bond? If you go from left to right, that puts the double bond at position 4. And if you go from right to left, that also puts the double bond at position 4. Now, which direction are we going to go in to find the right name for this molecule? When you go from left to right, that puts only the methyl group with the lowest possible number with the second substituent at position 5. The numbers that you get for the substituent for numbering the carbons from left to right is 2, 5. The substituents are put at 1 and 2 position and the other one at 5 position. But when you go from right to left, that puts the bromine at position 2 and the ethyl group at position 4. So obviously the number 2, 4 is a smaller number than 2, 5. So you have to go from right to left for this molecule. So where is the position of the double bond now? 4-octene, right? And leaving that 4-octene, we have 3 substituents. We have a bromine, we have an ethyl group, and we also have a methyl group. Which one is going to come first? Obviously, the bromine is going to come first, which is at position 2. So it's going to be 2-bromo. And then the ethyl group, according to the alphabetical order. So 4-ethyl, and then 7-methyl, 4-octene. Now let's go on to a slightly complicated problem. How are we going to name this compound? By default, this is going to have the parent name of cyclohexene because you have 6 carbons and a double bond is present in the ring structure. And this double bond by default is going to occupy position number 1. And we have to identify whether it would be this carbon which is counted as 1 or it would be this carbon which is counted as 1. Now let's say that we are going to put this carbon as 1. You cannot go in this direction because that is not passing through the double bond. You have to obviously go in this direction. So let's go in this direction to get the name of this molecule. So this is going to be, this is a bromo, this is a methyl substituent, and this is a chloro. So bromo group is present at position 3. So this is going to be 3-bromo. And after bromo comes chloro. So 3-bromo, 6-chloro, then 5-methyl cyclohexene. Let's also do the numbering on the other side of the double bond. Okay, let's erase these stuff and let's number in this direction. Okay, if you choose this carbon to be number 1, We cannot go in this direction because that is not passing through the double bond. We have to obviously go in this direction to reach the substituents. So that way, this is going to be cyclohexene. Now the bromine is at position 6, so this is going to be 6-bromo. And the chlorine is at position 3. And the methyl group is at position 4. Let's put the numbers together. We have a substituent at 3, 5, and 6. And here we have a substituent at 3, 4, and 6. So which one is a smaller number here? So you look into the first number, that is a tie. And you look into the second number. So obviously this one puts the substituent at the lowest possible number than this one. So obviously you have to adopt this as the proper way of numbering this compound. Okay, where you're going to start this carbon to be number 1, and you're going to pass through the double bond, reach the different substituents in the cyclohexene ring.